Okay, so good afternoon, and just wanted to kind of go over the plan for the next week and a half. So the next three classes, the last three classes, we will all be together in person. So Wednesday we'll be together in person because I need you to turn in your chapter 11 review worksheets. And my plan is that we're going to work on those together in class. So that's the benefit of being in class, we're going to work on those in class together. So I thought today if we can go through 11.2 and some 11.3, and then we can work on the chapter 11 review worksheet together in class, because that one, as you start working through it, you'll see you have to decide which section it's from, and you're going to have to kind of use that thought process that we did last week to decide what page of the gold sheets that you're going to be using. So I think it'll be valuable for us to do that in class together. And then next Monday, we'll work on the sample final exam together in class on Monday. So we'll be in, I don't see why we couldn't be in person for Monday. And then Wednesday, I mean, unless the weather's horrible or something on Monday, but Wednesday, we're definitely together because we got to take the final exam. So gosh, I can't believe it's already here. So all my people that are not having their video on, everybody can give me the thumbs up that they've got their StatCrunch open and their worksheets open. And here's Andrew. Okay. And everybody's registered for their classes for winter, I hope. I'm curious to know, are you? Okay, so I'm going to share my screen so that we can work on page 705. And I think I already attached the videos from my 7-week class, didn't I? I don't know if I did the chapter 11 videos or not that I've been attaching in JetNet of my previous semester. Did I do, Lainey, did I do chapter 11, Lainey, or was it just 9 and 10? I did 11 too. Okay, so they're out there. I don't know if anybody's watched any, if they were useful. But they are my previous semester, a 7-week course where we went through the same worksheets. Okay, let's look at these true and false questions, kind of get warmed up. So 11.2, we're all about two samples again. So we talked last week about that. Our first question that we're asking ourselves is, can anybody remember? What's the first question we're going to ask ourselves when we're kind of working through our little rubric that we created?
If it's proportion or mean.
Awesome. Okay, so that's our first question. So we're going to be asking if it's proportion or means. Today it's all about means. That's why we're going to do the chapter 11 worksheet together and Wednesday, so that you have an opportunity to really think about that when there are problems that you don't know. And then our second question is, does anybody know that? What's the second question? First one is proportion or means, and what's the second question? Oh, somebody's answering in the chat.
If it's one sample or two sample.
Oh, yeah. And I just see now Lainey had it for last time. I'll repeat. Okay, so one sample or two sample. So today's all about, we're talking about all about means, and we're talking about two samples. But then when we get to means and two samples, we actually have two choices. And the two choices are matched pairs or independent samples. And so matched pairs are going to look something like what's on problem number 2 down here, where we have somebody that you measured a before and after. It might be siblings that you measured, but they're actually paired together. So observation 1 is 2 data values that go together, and observation 2 are 2 data values that go together. So that's what we call matched pairs. Okay, and you'll see that on page 279 is the hypothesis test for matched pairs that we're going to work on today. And then there's also on 249, I'm sorry, 274, I knew there was a 4 in there. 274, we're going to talk about the confidence interval for matched pairs in 11.2, and then we're going to also talk about the confidence interval for 2 independent means in 11.3. Okay, so those are pretty much the 2 pages we're going to toggle between early on. So let's look at our questions here. 1A says paired data are data for which each value in one sample can be matched with a corresponding value in another sample. Let's see, everybody should either vote or raise your hand. Tell me. I should have set up some little quizzes. We could do a little voting system. Anybody have any ideas on that one? True or false on 1A?
True.
Anybody second that? True. Paired data is where one value in a sample can be matched with a corresponding value in another. That is true. Okay. B, to compute the test statistic for a test with matched pairs, we must compute the standard deviations for both samples. What do you think? True or false? Test statistic. So if we look at what a test statistic is here on 11.2.
Oh.
And why do you think it's false, Ashley?
Because I don't think we need a sample standard deviation every time, do we?
Anybody want to chime in on that? Do we have to find the standard deviation of both samples when it's,
Well-
go ahead, Lainey.
When you're like typing it into StatCrunch, you have to have the mean, the sample size, and the standard for both samples.
Oh, you do? If we're
Just mean.
doing it with no data, if we're just doing it with summary? That's a good question. So I would say false on that one. We only need the difference between them, but let's go to StatCrunch for a minute, because so if we went to stat and T-stats and two sample, and this is going to be paired data, right?
Yes.
Because paired data, I only have the option of putting in one column and two column raw data. I don't have the option of putting in, right? I don't have the option of putting in summary statistics. So that's one interesting thing for you all to learn, is we won't have summary statistics to put in. We'll have to have raw data. So that's good to know. But this is a false. Because we are only comparing differences. So like down here, either we're doing it or we're letting StatCrunch do it. And StatCrunch is going to take these differences, this one row here, and they're going to treat it as its one data set. So if we were using our TI-84, like in previous semesters, we would actually be doing the same procedure as we would in chapter 10 when we had mean data as well. And we would treat it as one sample because we're just taking the differences and we're only using this row right here. So something to consider. Heights of pairs of biological siblings is an example of independent sampling. I think this is independent sampling. Heights of pairs of biological siblings. Lainey says no.
I say no too.
Anybody want to back them up?
I say no.
With why not? So anybody want to back these three up, and why not? Why?
Well, because it's because they're biological siblings.
Okay,
And
so
then
they're
they're the
actually what kind of?
So they're part of the
sampling?
same family, so it's not independent sampling.
Okay.
They're
excellent.
matched pairs, right?
Yep. So yep,
Yeah.
they would be considered matched pairs because
Okay.
there is some relationship, right, on the heights of biological siblings to each other because of their parents. So yeah. Excellent. So something to think about. Okay. So our first set of data here, says a group of 8 individuals with high cholesterol levels were given a new drug that was designed to lower cholesterol levels. So cholesterol levels in milligrams per deciliter were measured before and after treatment for each individual with the following results. Okay, so it's asking us, we didn't have to calculate the differences, but we're going to calculate these and then we're going to see how they're going to do it for us in Desmos. So when it doesn't tell you if you want to do before minus after, I usually will take the before minus after just because it's top subtracting bottom. When it's a vertical thing like this, that's just my own choice. So I'll let you work on those for a moment. And we're going to go to that data set in so I get 66, 59, 6, 46, 38, 9, 13, and 7. So it says construct a confidence interval for the mean difference in cholesterol levels. Assume requirements are met. I need you to show the formula substitution result. So we're not doing the test on page 279. We're actually going to page 274 and we're looking at a confidence interval. And we're going to use the formula here. So you can either use the SD divided by square root of N. I'm just going to use a standard error because that's what pops out of StatCrunch. So my formula is going to be D bar plus or minus my critical T value, which we can get from StatCrunch, times my standard error of the D bar. And if I want this in particular without doing it within the confidence interval for my critical T, remember I can go to StatCrunch. So I'm going to go there. Oh, what's not random? Linear, you're talking about this one right here or the last one? The pairs of siblings. Okay, I figured so. Okay, I just didn't catch it. I didn't know if it was some of you were trying to alert me. So let's go to here. So I'm going to go to my data and I want to go to stat and calculators, and I'm going to do a T calculator because I want to get my critical T value. So our critical value, they said to do a 95% confidence interval. And so I'm going to do a between. And so I'm going to put 0.95 in the middle. And then I am going to put my degrees of freedom. And, ooh, you know what? Oh yeah, when it's this degrees of freedom, it should just be N-1. We have to work, it's different than some of the other ones. So there's 8 people that they took in the information on, so our degrees of freedom should be 7. And so our critical value should be 2.34, I'm sorry, 2.365. Okay. So let's go to stats. You can see on your gold sheet, it tells you exactly what you're going to do there on page 274. It says stat and T-stats and paired. So stat and T-stats and paired. And I'm going to use my before in my column 1 and then my after. And I clicked on save the differences. So it should actually put them in bar 3. And then our confidence interval is for 95%, right? Look at that again. Okay. And there we go. So notice it filled in the data in column 3. It said, here's your differences, and that should match what we came up with on our paper. If not, then that's good information to know. And then here's the mean. So the mean of the differences. So that's like taking your difference column and running a summary statistics and getting the mean and mean from that is at 30.5. So that is our point estimate right in the middle of our confidence interval. And then our standard error is 8.753. And then we have our lower bound at 9.804 and 51.196. And I'm going to go back and show you my paper. Any questions on that?
I have a question. So doesn't the 30.5 go with the 8.753 like in the equation or no?
No, this is our point estimate. That's the middle of our confidence interval. And then this whole thing together is our give or take. This is our margin of error, which is the standard error times the critical value.
Okay, but okay, it just says up there like standard error and then it has the D bar in it with the right there. Yeah,
Yes.
so I just
Yep, this standard error of the D bar is that number right there.
okay, got it. All right. that makes sense.
Okay.
Yeah,
Yeah.
it's saying, so the standard deviation is just the standard deviation of our sample.
Right.
The standard error of the D bar is what would a bunch of samples, what would their error be?
Okay, got it.
Good question, because it is a lot of symbols going a lot of different directions, and that D bar is showing up twice. So great question. This is its own entity right here. Everybody's good with that so far? So now the question of the question is, based on the confidence interval, is it reasonable to believe that there's a difference in the cholesterol levels before and after the drug? Explain. What do you think?
Would it be no because it doesn't contain 0? Or 0 is not like within the limit?
You're right, zero's not in the limit. It's not in, it's in our confidence interval. Does that
Right.
mean there's not any difference?
No, that means there is a difference.
Okay, so
Yeah.
it says, is it reasonable to believe that there is a difference, right?
Okay.
So I know it's, if you don't read it, because sometimes we write it assuming there is a difference, sometimes we write it assuming there isn't. So yes,
Okay.
we can say there is a difference in the new drug with lowering cholesterol levels. And the reason why is because 0 is not within the interval, because 0 is not within the interval. So when we answer this question, it reminds me, I wanted to touch base on the chapter 9 projects. I messaged, I graded all those over the weekend along with your chapter 10 review worksheet. If you're at the campus before class on Wednesday, those are up in my mailbox, so you can stop and grab your chapter 10 worksheets if you want to be able to check those out. The chapter 9 project, I put feedback in your project, which for some of you might be helpful for your chapter 10 project, because we're still dealing with qualitative proportion data, right? In chapter 10 and 11, it's still our candy data. So that might be helpful. And making sure that you know that this is a, because 0 is not within the interval, is a typical answer. So you don't have to jazz it up at all. You just have to tell me that yes, I think there's a difference because 0 is not in the interval. If there were no difference, 0 would be in there somewhere. Any questions on number 2 with the confidence interval? Okay. Let's look at next page, question 3. This is also in StatCrunch. So it says in an experiment to determine the effect of ambient temperature on the emissions of oxides of nitrogen of diesel trucks, 10 random trucks were run at temperatures of 40 degrees Fahrenheit and 80 degrees Fahrenheit. The emissions in parts per billion are presented in the following table. So we can see that it's matched pairs because you can, well, for one, we have raw data, and 2, we can see that truck 1 has 2 observations, right? So 1 truck, 2 observations, 1 truck, 2 observations. So something that we want to consider. Part A says, find the differences and place them in the table. Well, I'm not going to do that because we have data in StatCrunch and it's going to be in there for us. So let's go find that data so we can check it out. And it's on the second page, third page, I guess. There it is, truck temps, number 3, truck temps. Okay. So we'll fill that. We don't necessarily need to fill it in. Now on the final exam, I may have a problem where you have to fill in the differences. And if you let StatCrunch do it, that's fine, but just make sure you get them filled in. I would recommend if the numbers aren't real large, fill them in on your own. Then when you double check it with StatCrunch, that will kind of help make sure that you've done it in the right order. Okay. So part B says, verify that the requirements needed to conduct a hypothesis test are met. A normal probability plot of the difference values is given above. So because we have matched pairs data and it's quantitative and they're asking us to run a hypothesis test, that's how we know we're going to go to page 279. So let's just write, I'd probably write at the top here, this whole thing is about 279. So also remember with two sample data, we're going to have 4 pieces of information that we have to verify for requirements. And the first one is a random sample. And did they take a random sample? It says random trucks, but they didn't really say random sample, but we're going to go with it. So we'll say yes. The second one is we need to show that we have dependent samples. They're matched pairs. So that's where I'm going to say dependent. And this is going to be your typical answer for matched pairs, dependent, and just tell me what it is. So in this case, it's 1 truck measured twice. And then our third one is independence within the samples. So it says is sampling with route replacement. So if we've used the truck, we're not going, besides getting the before and after, we're not going to use it again. So it wouldn't be the same truck wouldn't be truck 1 and truck 7, right? Or truck 2 and truck 10. And so that's where we have to do the 20 times N, which is 20 times the 10 trucks. So 200. And I'm just making sure that my population size is at least that. And I would definitely say that we have at least 200 trucks out there, probably just in Hillsdale itself, right? I don't know about diesel trucks, but maybe. Okay, and then the fourth item is the normality question. So to prove that our data is normal, we would look at our sample size, but in this case it's 10, so it's not bigger than 30, right? And so we have to look at the normal plot, which they gave us up here, which is really nice. And does that normal plot look pretty linear to you all? I would say it looks fairly linear. So normal plot is linear. Okay. So letter C says the researcher conducting this experiment claims that the mean emissions are higher at 40 degrees Fahrenheit. Test this at the 5% level of significance, showing all steps, graphs, formulas, and work. Okay, so this is where page 279 comes into play. So the first thing, which is the most critical piece where we can trip up the quickest, is with our hypothesis statement. So if we don't get this one nailed down correctly, it kind of leads us down the wrong path. So do we think it's a less than, a not equal to, or a greater than right-tailed?
A greater than.
And what makes you think that?
It says that the researcher conducting the experiment claims that the mean emissions are higher at 40 degrees Fahrenheit.
Okay, so higher. Higher at 40. And because when we take our difference, we're going to have it 40 minus 80, because it usually does mean one, or column 1 minus column 2. And this one's bigger, we would have guessed that our difference is greater than 0. So that's important to know which one you're choosing, because it makes a difference when you get to StatCrunch. So let's go ahead and write out the hypothesis statement here. So Mune's hypothesis, the null hypothesis is the mean difference is equal to 0. And the alternative that we're looking at is the mean difference is greater than 0. So, okay, so 2 is alpha, and they told us that they want us to test at the 5% level of significance. So that's where we get 0.05. Our test statistic is T0. So we want to know our D bar. So D bar over the standard error of the D bar. And we'll fill that in from our output here. And then once we do that, we're going to look at our graph. So I just have to draw my picture and get that all done, because this is a right-tailed. It's going to look like that. And our p-value, once we know it, we're going to compare to the alpha, which is 0.05. And we're looking to see question mark, is it less than? And then we will go ahead and write up our conclusion with step 6. Everybody with me so far? I get a thumbs up from everyone that's not.
I have a question.
Mm-hmm.
So on the test, on the exam, what will you give us this data? Because you said the only way to do it is with raw data, right? So we're gonna get it.
If it's this, if it's a match
Right.
pairs, I have to give you raw data.
Okay. Just
Yep.
making sure about that.
Mhm. Hint, hint. So note to self on that. Okay. So let's go ahead. Shelby and Adam, I didn't see you thumbs up. Are you ready to go to the? Okay, so let's go ahead and I'll share my screen to go to StatCrunch. And voila, there's our data. So we're going to go to stat and T-stats and it's paired. And so there's our option, or here's our situation here. So we're going to go to 40 degrees and 80. And then I do want to see the differences just so I can see them. And we're doing a hypothesis test compared to 0, but we think it's greater than 0. So the main thing that you have to do here is choose your 2 columns and then the greater than. And if we were checking to see our difference was something other than 0, like we think our difference is 10, right? Then we would put 10 there, but we're just checking to see if there's a difference between them. Everybody with me so far? Okay. So voila, there it is. I'm going to make it, I'm not sure making it bigger helped at all, but there it is. Didn't really make it bigger, I just put it in a corner. Nobody puts baby in a corner. Yeah. I did just watch Dirty Dancing yesterday, came on, so. Okay. So it was fitting. So our T0, we have our mean. So that's going to go to the D bar, which is in the numerator 34.29 over the standard error of 13.482. And the T statistic is 2.543. And the P value is 0.0158. And I'm going to make this small so that we can see. They did give us the differences. Notice that they did that in right there in our column. And I think the one that really threw them off was this one truck right here, right? Wow, they had a difference of 103. All the other ones were fairly small.
So T0 is equal to T stat, like of in here.
Pardon me?
So T stat, the T stat number is where we put for T0.
T-stat is what we put for T0. Yep. So let me go back to my
Okay.
paper. I want to make sure everybody had a chance to double check that. Good question. So I put my D bar, which it says mean. So it's not going to say D bar, right? It's going to say mean. And then your standard error goes in the denominator. And then there's our T0, our T-stat. Yeah, this is our T-stat. And then there's the p-value. And that's what's in this area right here in the curve. And so, do we reject or do not reject?
We do reject.
We do reject H0. So there is sufficient evidence to support the claim that trucks have, is it emissions? Yep, higher emissions. Emissions at 40 degrees Celsius. Which is interesting. So when it's colder, there's higher emissions. So I guess we should like it, but there's global warming. I'm totally joking. That was just like a random thing. That kind of contradicts though, doesn't it? It's like they want to lower emissions, but they don't want it to get hotter. So I don't know. I think we're disagreeing with ourselves. I do find that kind of interesting though. I never thought of it that way. Okay. Any questions for me on the hypothesis testing one? Any questions? Any questions? Anyone? Okay. Let's just do number 4 real quick. You guys didn't, you haven't put this data in. We're running early, so we're fine. So this data is not in. This is a new data set. So this will be good practice for you to put it in because on the final, you might have to put in data. So I'm going to share my screen so you can see where to go for that because there's been very few times where you've actually had to put your own data into StatCrunch. So in StatCrunch, to put in new data, you're going to go to data. Wait, you're going to go to StatCrunch. Is it edit? I thought there was a thing that actually said new. Well, the good thing is we could just put it in new rows, right? As long as we're choosing the right rows, let's just do that. So I'm going to put my pre-test in and then my post-test. Oopsie. So 25, 26, 30, 31, 27, 34, 20. Oh. Okay. Everybody have their data in. So Shelby said it says new data table. Where did I miss that, Shelby?
Under StatCrunch.
Oh, down below. Thank you. Awesome. I'm like, I know I've done it before, but like I don't do it very often either. I got all these data sets in there. Thank you for finding that. Okay, so let's go back to our paper here. And it says a group of business managers is taking a course on tax law for their businesses. A random sample of the managers are given a pre-test and a post-test from the course. Can you conclude that the course made a difference in the business manager's knowledge of tax law for their businesses? Use a 0.05 level of significance and show all steps, formulas, and work. Okay. So what do we think our hypothesis statement is?
think that it's greater than pretest.
I think it's greater than.
Mhm.
My initial thought would be the greater than, but it says just made a difference. So I guess,
So
I
it's
don't
just-
know, but I think made a difference does mean that they improved, right?
Because it could, would it, I feel like it couldn't be, doesn't equal because it would have to be over 0.
Yeah, well, if it was a not equal to 0, then we would say that made a difference means they scored lower too, right? It just doesn't equal what they did. So, but I think
Right.
made a difference, they're insinuating that they improved their scores, right? Made a difference. So sometimes when we see the word different, we automatically just think that is there a difference between the two? But in this one, made a difference means that we think that they should have improved their scores, right?
Mhm.
So if we take a difference of pre minus post, do we think that difference is going to be greater than 0 or less than 0? Because remember, in StatCrunch, it always does the one column minus the other, unless you tell it the post column comes first.
So it would be less than 0, right?
So yeah, so if we
Would be
do
with the. Okay,
yeah, so if you do pre minus post, then it should be less than 0. If you do post minus pre, you're gonna do greater than 0. So you would have to tell it that, right? When you give it your columns. Okay, so I'm gonna do pre minus post is the mean differences are less than 0. And then our alpha is 0.05. And I am going to let you all work on this here for a minute on your own and see if you have any questions. I'm gonna go get water. Let me see what Harley is doing.
So Mrs. Main,
Mm-hmm.
I missed how we got the data in StatCrunch. I'm sorry.
No, you're okay. We went to, you can either type right in one of the StatCrunch forms that we already have, or you can go to under the stat crunch column right here, you can go down to where it says new data table. But if you don't mind having multiple columns in a file, you can just do it right in. I just did mine in bar 5 and bar 6. So let's go to that. Okay, so I'm gonna let you all tell me, check with each other and see what we get for our, oops, T0. Oh, I thought I did that right. This one right here. Okay. So who wants to give me the D bar and all the, so I think everybody could take turns. There's enough items here. I'm going to give us the D bar.
Negative 1.7.
Anybody want to confirm that? Negative 1.7.
Mhm.
That's what Ashley said. Does anybody agree with Ashley? Any agree? Andrew, Shelby, anybody want to give us? So I'm hoping everybody can participate. This way I know, because we're on the Zoom, so we get the luxury of just sitting at home.
So the top is just the mean, right?
Mhm. So does anybody agree with Ashley that it's negative 1.7? Okay. So Ashley's off the hook. Who wants to help us with the standard error?
Put 0.919,
Anybody agree?
or
with
you
that?
could say 0.920, I guess.
Yeah, I guess if you round the 9.5 right up, so 0.92. Oh, okay. Shelby's off the hook. Who wants to give us the test statistic? Okay, Lainey.
I just put 2.5. But I don't know how many. Do you want it to go like 4 over or?
Oh, I didn't get 2.5 and I might have typed mine in wrong. Did anybody else get 2.5? I might have typed mine incorrect.
No.
Did you get the same mean and standard deviation that we did, Lainey?
I was looking at the wrong, because you know how I had the columns over here and the columns over here. I was looking at the wrong.
Okay. Shoot,
Paired.
no, that's good because I'm like, I was just not that. I mean that this is the time to make the mistake and go, oh, I used the wrong.
No,
thing.
I was totally just looking at the wrong thing. One sec.
Okay, so what
I
is it?
deleted the other. No, I deleted the other one and I have the wrong one on my screen.
So somebody else want to help us with the T0?
Yeah, I got it.
Okay,
1.85.
you got what?
1.85.
Is it positive 1.85? Did you do a greater than 0 then for yours?
Yeah.
And then did you do post-test minus pre-test?
Yes.
Okay, so that's okay. So mine is a negative 1.85. 1.85 because I did a less than 0.
So it doesn't matter then, because it's.
So as long
positive
as yours
1.8.
said greater than here, and then you got a positive 1.85,
Okay,
your p-value should come out to be the same result. Mhm. Okay, so I'm looking for the other folks to help me out here. Somebody's got something in the chat. Okay, Jennifer said negative 1.85.
I can do the p stat or the p value, sorry.
Okay, let me get my picture here. And we'll take the p-value for sure. Okay, what is your p-value, hon?
0.0479.
0.04. And I got 0.0488.
What the heck?
so did I.
That's what I
Maybe-
got too.
Maybe it's just a digit. Maybe you typed a digit off is all. Because it's super close. So that's my guess. And then can somebody tell me what is my alpha, Adam or Genevieve? What am I testing at here? What am I comparing to? Cassie's the, so somebody can type in the chat, what am I comparing to for my alpha? Anyone? Cassie said 0.05. Okay, so everybody agree what we're comparing to is 0.05?
Yep.
And is it less than like we wondered? That's the question, and it is. So what is our response then?
Reject H0.
Reject H0. Okay, so we reject H0. So there is sufficient evidence to support the claim that the course made a difference in the business manager's knowledge. So, Andrew, did you get the same p-value? Yep.
Yes.
Okay. So as long as you, however you're subtracting, you make sure your sign matches, then our critical or our t statistic will just be opposite signs of each other, and that means our p-value should still be the same likelihood. So great job. Good job. Good job. Okay, any questions so far over 11.2? The very back page of your gold sheets is where our hypothesis test for two independent means are going to be. And then if we have means and their independent data sets and we want a confidence interval, we're going to go back to that page 274 where we were working earlier. And we're going to choose the bottom one that we highlighted last week when we made our little rubric. So let's go ahead and I'll share my screen. So this data is a little bit different. And how might you be able to decide by looking at this data that it's not the matched pairs? There's a couple of things that you might notice. Anybody find, notice two things that are a little bit different that might stick out for us that I would know that it's not matched pairs like we thought before?
Because there's two separate fertilizers and then each fertilizer has two separate fields.
Two separate, okay, so say it again.
I said that each fertilizer has two separate fields, so it's not like, they're not the same.
Okay, so they specifically said that they two separate fields. So it's not like it's one field and we did a fertilizer and then we did another fertilizer. And I don't know a whole lot about farming, but I do know a little bit because there's farms all around me too. If I think this is true, that like usually like seed corn, they can do seed corn in a field 1 year, but then they have to skip a year and do something else there before they can do seed corn again. Does that sound right? So anyway, anybody know that answer? So I think that they have to kind of alternate them.
Not anymore, but they used to.
Oh, okay. Well, that's good to know. So that's one way, you're right, Lainey, that we can see that they told us that the land is in two separate fields. So it's not the same field fertilized twice. That's one way. How else can we tell from looking at the data here that it's not the same? They're not matched pairs.
There are two linear plots
Oh, that's true. There's two normal plots, so that gives
or
it
normal
away.
plots, yeah.
They're
There's
not
two sets
dependent.
of differences.
What was it, Andrew?
There'd be two sets of differences.
Well, but we wouldn't have anything to difference though, right? That's, so it wouldn't really be two sets of differences. How many, are they the same sample size? That's one thing to look at. Do we have the same number of plots in fertilizer A as fertilizer B?
Mm-mm.
We don't, do we? So what is it, 16 for fertilizer A?
Yes.
12 for B, I believe. Okay, so that's gonna, one thing to give it away. The match pairs will line up with each other because they'll say observation 1 and then the two values that go with observation 1 and then observation 2 and the two values, where these are not, you don't even know what's matched with what, right? So a few clues in how the data is presented to you that will clue you in that it's not matched pairs. Okay, so it says verify that the requirements necessary to construct a confidence interval are met. So that's how we know we're going to go to page 274 for the confidence intervals. This one right down here. For two independent means. Okay, so let's go ahead and we're going to verify that. So the four things are, the first requirement is a random sample. And did they mention the random sample? They did. They said they randomly selected plots, right? And it says the samples are independent of each other. So we can say two separate plots, two separate fields. So it sounds like within one field, there's different plots, right? And then within another field, there's different plots. So in two separate fields. So that gives that a check. And then the independence of the population, we have to do with both data sets. So we're going to do 20 times the sample for fertilizer A, which is 16, equals 320. And I definitely think that there's at least 320 fields or plots of land. I'm guessing it's fields we should go by. And then 20 times sample size of fertilizer B would be 20 times 12, and that would be 240 And again, I definitely think that there's at least that many plots as well. So that's safe to say. Okay. And then the fourth one is the sample size for the A fertilizer is 16, which is less than 30. And sample size for fertilizer B is 12, which is also less than 30. So that's why we have to look at our normal plots from up above, right? And then do we think that they both look, fertilizer B looks a little weird right here, but for the most part, I'll say that they look normal. They look linear. But something to consider there on fertilizer B. Okay. Now it says find the following information. So we need to have the sample size for A and B, which is 16 and 12. We need to have the mean for each and then the standard deviation for each. So when we go to, no, they aren't the same sample size. I don't know when, I'm sorry, I don't know when, Shelby, when you asked that question, but if it's this one, no, they're not the same sample size. You can see that 2, 4, 6, 8, 10, 12, 14, 16, and then 2, 4, 6, 8, 10, 12.
She said that when you asked us why they weren't matched pairs.
Ah, awesome. She was catching it. I just didn't see the chat. Good catch. Good catch. Next time, interrupt me. Okay, so let's go to the data in StatCrunch. Because if we were to if we were to go to StatCrunch and do T-stats and do 2 sample with summary, oh, actually we have data, right? Data. I'm going to say we've got fertilizer A and fertilizer B. And we've got a confidence interval, and they wanted, what was the confidence interval they wanted to run? Is it on the next page? No. Oh, 98%. So it's in that little box there, 98%. When I run that, we can run it again here in a minute. I want you to see that they don't give me the individual means of the two, right? And the standard deviation. So that's why don't copy this yet. Let's go to stat. We have to remember that to find our individual sample size means and the standard deviations, we're going to have to go to summary stats. So sometimes you're going to have to do that for this type of data. And I'm going to go to columns and I'm going to choose both. I'm going to click on both by hitting shift, and then it will put both of them there. Oops, I want to do them. I'm gonna go back. I want A on top. So summary statistics, columns, and then I choose, there we go. Okay. And I'm gonna hit compute. So there we can see our data. And because we want to enter our data in the box down here. So the mean is 457.1, I'm sorry, 0.313 for fertilizer A, and fertilizer B is 405.333. And these are pounds, right? It's like they're wondering if these two fertilizers produce more of an abundance of oranges than the other. Everybody with me so far? Okay. And then the standard deviation for each, the A fertilizer is 38.48 and the B fertilizer is 13.97, which is much smaller. So it looks like the plots from the fertilizer B, they're much more centered around their mean, right, than the others. And you can see that from the median too. The median and the mean don't look that far off on the fertilizer A, but their standard deviation is definitely much higher. Okay. So just making sure we all have the same values filled in. And then let's go back to our confidence interval. So stat and T-stat and 2 sample with data. So it's not paired, but it's 2 sample with data. So fertilizer A, fertilizer B, and we're doing a confidence interval of 0.98. And so the only thing left to fill in our paper right here is our lower and upper bounds right here. So our lower bound is 25.596 pounds up to 78.362. This is our difference, right? We're predicting the difference between them. And which one, by looking at these numbers, which one does it look like is higher? We're not asking you this on letter C, but I am asking you this. With the difference being positive, which one does it look like is higher, the first one or the second one? Fertilizer A or B?
Looks like B.
Looks like B.
Mhm.
How can we tell it's B?
I guess because it says between A and B, so I assume they were listed in order of A and B.
Okay, so I think they are. So between A and B means that we would take A subtracting B, right? And I think that's what they did on it says mu1 minus mu2, which would be A minus B, and we got a positive difference. So which one would be bigger? We can tell kind of from the mean as well. It looks like A must be bigger because we took A minus B, and A, you can see that the average of the A fertilizer plots are bigger. So it looks like A is bigger, it's just an observation. So letter C says, based on the confidence interval, is it reasonable to assume that fertilizer A and fertilizer B differ significantly in their yields? What do we think?
I think yes, because 0 is not within the interval.
Okay, anybody agree with Ashley on that? She thinks yes, because 0 is not in the interval.
Yeah, but it says significantly though, right? Doesn't that mean something?
Well, we're 98% confident. So I'd say that's pretty significant. So our alpha in
Okay.
this case would be 0.02. So, and because 0 is not in the interval, we can definitely say that there is a difference.
Okay.
So I would say it's significant.
All right.
So we'll say with 98% confidence, we can say that the fertilizers differ in their yields because 0 is not within the interval. So that's a good question. So technically, you could use confidence intervals to answer your hypothesis test questions because depending on how you write your confidence interval, you could end up being able to answer those questions similarly. Any questions? All right. How's everybody doing?
Everything.
Question? Okay, so how about we look at number 2? This gives us an opportunity to look at this type of data again. So number 2 on page 716. So I'll let you all read through and see if we can answer our questions. So where does it tell us how many samples we have? Or I mean, whether we're talking about proportions or means.
I mean, it talks about mean multiple times.
Excuse me, what?
It says here the mean distance, test whether the mean distance greater than the mean for the control. So it's definitely not a proportion, it's a mean.
Okay, mean distance. And right here, greater with, we're testing the people that that use the treadmill walking, right? Is greater than the mean for the control group. Good job. So we're talking about means. And we're talking about 2 samples. And then the extension question, once we know we're talking about means and 2 samples, is are they matched pairs or independent?
Independent.
Independent. And we can tell that too because our sample sizes are different, right? So they're independent. Okay, excellent. So we're going to that last page of our course pack. Can't believe it. Last week here. So we have to learn how to write our hypothesis statement. So which one are we using?
Right-tailed.
I think it's a right-tailed. So we should probably decide which one is going to be, so group 1, right? And group 2. Group 1, they said, was the treadmill group. And then the other one was no walking. I don't know if it wasn't any walking at all or just not with the treadmill, but it said they did not walk on a treadmill. So I'm guessing that they probably didn't do much because they didn't feel good, right? Their legs didn't feel good. And the one group, they're like, legs don't feel good, so let's get you walking. Okay, so Andrew thinks it's right-tailed. So if we do group 1 minus group 2, we think the treadmill group is going to be greater than the no walking group. Is that what we're testing? Test whether the mean distance walked for patients using a treadmill is greater than the mean. So I would agree with that. So that's probably the trickiest part of these chapter 11 ones is figuring out that hypothesis statement. And our alpha is at the 0.05 level, 0.05. And then our test statistic, do not worry about filling this in because this is really getting hot and heavy and big and crazy here. So just give me the T0 from the calculator from StatCrunch. And then we've got our picture, which is going to be a right tail. And then we're going to compare our p-value here, right, to the alpha, which is 0.05. And we're looking to see if it's less than, that's our question. And then I'm going to have a conclusion. And notice that I started this thing over on the right, because if you go to StatCrunch for this and you go to enter in your data, it's got like all these boxes, right? So the boxes are going to ask for the sample mean first. So sample mean of the treadmill, the sample standard deviation of the treadmill group, and then the sample size, which that one was 48. And then the sample mean of the no walking control group. So we'll call those T for treadmill and C for control, and sample for the control group. And then this, the standard deviation for the control group. And then the sample size was 45 for the control group. Okay, so I'm just doing this for myself off to the side because when I go to enter it, and plus if you have it off to the side in your paper for the final, that's kind of nice because then I can just go and check. On the final, just a suggestion, I haven't really had anybody that's like, oh, I got this all wrong and it was all corrected in my StatCrunch. But if you do want to take time to save your work in your StatCrunch, you could do work all over in a couple different files, right, and save them, and then you could always send them to me. Okay, so let's go to share my StatCrunch here so we can do this together. Oops. Not fertilizer. So in a blank one, and I'm going to stat and T stats, and it's 2 sample, and this time it's with summary. So T stats, 2 sample with summary, and look at all these boxes we get to fill in. So our the sample mean for the treadmill group was 348. Right, and their standard deviation was 80. And then the mean for the control group was 315. Their standard deviation was 87. And then their sample size was 45. So they definitely, the distance that they could walk was definitely lower, but we don't know if it was significantly less, right? So that's what we have to figure out. And we're doing a hypothesis test. And our difference is equal to 0, and we're doing greater than. And compute. And this is the output that everybody else received. So we have our T0 is 1.90. And our p-value is 0.0303. I'm going to share my screen just so everybody can see what I'm writing. Hopefully let me know if your StatCrunch did not come out to be the same, because we want to make sure that we fix it so that we're all in agreement. And do we or do we not reject H0?
We do reject.
We do. We do reject H0 because our p-value is less than alpha, right? Our likelihood of this weird thing is less than alpha. Okay, so there is sufficient evidence to support the claim that walking on the treadmill increased the distance that patients could walk. You crushed it. Anybody have any questions so far? So what I'm envisioning for Wednesday is that everybody, if you can take a few minutes and kind of go through each problem that is on the chapter 11 worksheet. If you've already started working on it, that's even more fabulous. You're ahead of the game. If you haven't, if you can take some time to kind of go through each problem in the chapter 11 review worksheet and decide, using our little matrix that we came up with last week, what page would I be going to? What do they want me to do? Is it quantitative, qualitative, means, proportions, one sample, two sample, yada, yada, yada. So then when we get together on Wednesday, we can actually work on those and verify that everybody knows how to pick all that out, because that is the key to this final exam, is being able to decide, what have I got going on here? What do they want me to do? And what direction am I going to head? Because using the sheet itself isn't usually the struggle for most students. It's deciding which sheet I'm heading to. And so we'll do that on Wednesday. And then if we have time, we're going to most certainly start on that sample midterm or the sample final review so that everybody can get working on that, because next Monday we won't have time to go through that whole thing. Also, if a student wants to remind me, I told my morning class, but nobody sent me an email. If somebody wants me to send me a reminder email, I will upload videos of my going through the final review, final sample review with my 7-week class. And then if people want to start working on it, you can start checking answers and stuff with that review video. Does that sound good for everyone?
Mhm.
And then as I think I mentioned it before, but the final exam is similar to the midterm. You can come and go throughout the day as you want, but I just ask everybody starts their midterm if you can start by 3, but I know the class technically doesn't start till 4, so it's not the end of the world. I will stay till everyone is done that day. And it's not, I mean, it's technically over the whole semester, but remember I said I'm focusing on the last half because I used to have people there like 3 and 4 hours for the final exam. It was a doozy. So, okay. If you want to stay and work on anything else, I'm happy to stay and answer questions. Otherwise, I'll see you all on Wednesday. And we're going to celebrate on Monday, Andrew's birthday.
Yay.
Coming up in a week. You told us so. Now you
I don't remember